The Aspen Power Clean Biomass Facility is conveniently located in Lufkin, Texas, between two large national forests, the Davy Crockett and the Angelina National Forest, and is surrounded by millions of acres of additional timber forest and the Texas timber industry. The plant is a 50 megawatt generator deploying Detroit Stoker vibrating grate technology with a 1,250 pounds per square inch boiler and a GE turbine generator set. The plant was completed in 2011 and generated approximately 90,000 megawatt hours before being idled and preserved in 2012. Following a rise in power prices, the plant was restarted by a world-renowned operations company and generated an additional 40,000 megawatt hours. The plant has always been under professional supervision and security while running and when not running. Although Aspen is designed as a baseload renewable energy facility, it was developed without a power purchase agreement and has operated as a merchant generator, delivering competitively priced power into the Electric Reliability Council of Texas, or ERCOT. The opportunity remains to procure a long-term power purchase agreement, or PPA. The plant is one of the cleanest biomass plants in the U.S., and the world for that matter, and uses an electrostatic precipitator and selective catalytic reduction, or SCR, for minimizing particulate, carbon monoxide, and nitrous oxide emissions. The plant receives clean wood waste by truck from multiple local sources, including sawmills, lumber and plywood processors, urban biomass collection sites, loggers, and land clearing operations. The Aspen plant is located on approximately 80 acres of land within the city of Lufkin, Texas. The site is large and has roads and heavy infrastructure to support the 50 to 60 trucks needed per day, delivering biomass fuel while the plant operates at full output. The Aspen plant has dual in-out Mettler-Toledo scales and software that automatically catalogs the amount of material delivered while keeping track of the in versus out weights. The software transfers data to Excel for ease of accounting and incorporation of important delivery information, including manually calculated moisture content for each delivery. The scale house serves as both the check-in point for truck deliveries and 24-hour security. A full-time scale operator is employed to check in and out all biomass deliveries. After trucks are checked in, there is ample room for trucks to queue during periods of high delivery activity while awaiting a position on either truck dump. The scales accommodate typical tractor trailers, as do the hydraulic truck dumps. A normal delivery is about 25 tons, and the normal weigh-in, offloading, and weigh-out process takes about 20 to 30 minutes. There are two hydraulic truck dumps that raise both tractor and trailer to about a 60-degree angle to completely offload all biomass material into a hopper. The driver of the truck must vacate the cab prior to raising the truck. There is a safety booth on each truck dump where the driver must remain while the truck is offloaded. The two truck dumps allow for redundancy and simultaneously offloading. A trained operator is in charge of coordinating delivery offloading operations and assuring the safe removal of biomass fuel. Biomass deliveries are managed through a local supplier who coordinates supply from various sources. Aspen has been able to minimize costs for delivered biomass through optimization of sourcing and contract negotiation. The Aspen boiler can burn high moisture fuel, 30% to 50% moisture, but is far more efficient burning fuel at lower moisture levels, or below 30%. The moisture content of fuel is difficult to control and has a major impact on the efficiency of burn fuel per megawatt hour. Normal output in tons per megawatt hour is usually between 1.1 to 1.5 tons per megawatt hour. Once the offloading is complete, trucks exit the ramp, drive up on the weigh scale, and then exit the site. The fuel yard management system is comprised of a series of drag chains, conveyors, a magnetic metal retriever belt, disc screen, hogger, and radial stacker. There is an elevated modern control room that is occupied by a qualified operator only during periods while trucks are being offloaded and material transferred to inventory via the radial stacker. The control room position, elevation, and plentiful windows offer a high level of visibility, allowing the operator to safely operate the fuel yard equipment. There is redundancy only in the truck dumps, hoppers, drag chains, and conveyors that remove material from the truck dumps and then transfer it to the single primary conveyor and radial stacker. Although this power plant is currently fueled by wood waste, any type of combustible solid material can be offloaded and conveyed using the existing fuel transfer equipment. The inventory is managed on a first-in, first-out basis, and the radial stacker, along with the front-end loader, are the means by which all fuel inventory is managed at Aspen. The fuel yard can store enough fuel for normal plant operations for up to approximately 15 days. Heavy rains swept through the Lufkin, Texas area just prior to the completion of this video. Some standing water is clearly visible, but there was no impact to the plant's operations. The fuel specification for the plant is 3.5 by 3.5 inches, either hardwood or deciduous, and generally below 30% moisture content. Moisture content is difficult to control and correlates to ambient conditions and rainfall in the fuel sourcing geography. Moisture content has a major impact on the plant's efficiency and is directly proportional to the fuel use required for generation per megawatt hour. The Aspen fuel yard has generally a low level of automation and redundancy, although equipment and management techniques are highly effective. Fuel transfer from the inventory pile to the reclaimer requires the use of a front-end loader. There is a single reclaimer drag chain where biomass material is fed by the front-end loader operator. The drag chain speed is adjusted to manage the fuel level in the boiler metering bin. The speed of the reclaimer drag chain can be manually or automatically controlled by the boiler master control system for effective delivery of fuel for a given steam flow and electrical output to the grid. The primary conveyor delivers material to the boiler metering bin prior to its entry into the boiler for combustion. Recent modifications were completed on the reclaimer drag chain and the transfer conveyor. These modifications included a new gearbox and drag chain, along with a newly designed enclosure and material deflection direction modifications, providing for a more effective transfer of fuel to the primary boiler conveyor and virtually eliminating spillover of the material at the transfer point. The plant is equipped with an emergency reclaimer, hopper, and conveyor for use in the event of a breakdown of the primary reclaimer and conveyor system. The emergency boiler fuel delivery system allows for continued operations while the primary system is restored to service. Generally, Aspen's power's fuel burn rate per megawatt hour ranges between 1 and 1.5 tons per megawatt hour. The primary factor affecting burn rate is moisture content, but also the makeup of the fuel. Aspen Power is one of the cleanest biomass plants in the world and has virtually no visible particulate emissions while operating thanks to the modern electrostatic precipitator. The facility generates Class 1 bottom ash and Class F fly ash that have been tested and confirmed as non-hazardous. The boiler is equipped with an automatic and continuous bottom ash and fly ash removal system. Fly ash is stored in a large silo and removed from the silo using dustless vacuum trailers. Bottom ash is removed utilizing drop-off open containers. For example, fly ash can be used as an additive in Portland cement mixtures, and fly ash and bottom ash can be used as fill in construction or road projects or for soil augmentation. Aspen Power is also equipped with a selective catalytic reduction unit that, along with ammonia injection, drastically reduces nitrous oxide emissions by about 90% and converts NOx pollutants into nitrogen, oxygen, and tiny amounts of CO2. Aspen's air permit requires the use of a continuous emissions monitoring system for the measurement of all permitted emissions exiting the plant stack. Aspen's air permit was recently amended to greatly enhance the number of allowable startups and increase certain allowable emissions limits. The air permit was also amended to allow for the use of natural gas in starting up the facility. This now allows for about 100 startups per year. Aspen's boiler fuel feed system is state-of-the-art with 28 individual metering bin screws, each controlled by a single variable speed motor. This fuel metering system provides for pinpoint fuel delivery of fuel across the boiler vibrating grate. All fuel deliveries, transfer handling, and metering systems are easily compatible with a variety of solid fuels. The boiler is a multi-fuel boiler and can burn a variety of solid fuels, including many different forms of biomass and refuse-derived fuels, or RDF. The boiler is also configured to burn liquid fuel, currently biodiesel, and can easily be modified to burn any other fuels such as heavy fuel oil or HFO and lighter oils like kerosene. This boiler can also burn natural gas. With exceptional fuel diversity options, the Aspen boiler can easily be adapted to burning a variety of solid or liquid or gaseous fuels, even simultaneously. This significant advantage in diverse fuel options provides for a high level of reliability in keeping the plant online should there be any disruption in the primary source of fuel. Aspen Power is a conventional power plant and utilizes a Rankine cycle boiler, steam turbine generator, condenser, and cooling tower heat sink for the steam cycle. The cooling tower has 3 sections, each with a variable speed fan for adjustment based on ambient conditions. Cooling tower makeup can be accomplished with well water or city water. The plant has a water discharge permit that allows for discharge of cooling water tower below down to a nearby stream or lake. This is the ground floor of the plant building. The scenes here are meant to show the various equipment and systems located on this elevation. Systems associated with the turbine, generator, condenser, feed water heaters, hydrogen skid, demineralized water, compressed air, etc. are generally located inside the plant building. Other systems, such as the boiler, fans, feed water pumps, grate cooling pumps, and ash removal equipment, are all located outside the plant building. The plant was designed and built with new equipment, piping, valves, motors, pumps, and support components. As you can see in the video, the layout of the plant is generally open and allows for the free movement of operators and other maintenance personnel. Systems are clearly marked for safe operation and situational awareness. High temperature piping is well insulated for safety. Aspen utilizes a reverse osmosis system for the production of deionized water and also has mixed bed demineralizers. There is a large storage tank for deionized boiler makeup water located outside the plant building. Generally, the plant is staffed with 22 to 24 operations personnel, including a plant manager, O&M manager, control room operators, plant operators, a budget analyst, environmental health and safety manager, instrument and electrical technicians, and maintenance technicians. Modern equipment is employed throughout the plant for the purposes of filtering and cleaning turbine lube oil and seal oil, instrument air, and generator stator insulation and hydrogen monitoring. Advanced chemical analysis of the boiler water and other systems in support of plant operations are employed at Aspen. Reliable and redundant air compressors, which produce dry compressed air along with large capacity station and instrument air tanks, are installed at Aspen Power. Safety at Aspen Power is of the utmost importance. All systems have been installed with safety as a paramount concern. There were numerous safety upgrades recently completed to the plant, including additional railings, escape ladders, eye wash stations, and readily available personal protective equipment. As mentioned, a great deal of thought went into the layout of the plant, and convenient locations were designed for access to boiler water and other systems for sampling and chemical analysis. This is the second floor of the plant building and is also known as the mezzanine level. This elevation is located between the ground floor and the floor where the turbine and generator are located. The mezzanine section contains additional equipment in support of the turbine generator operation, along with electrical and control system cabinets. The isophase buses and generator breaker equipment is also located on this elevation. Control valves for condensate and the number 1 feed water heater access are on this floor. The main steam stop valve is also located on the mezzanine level, along with access to the turbine lube oil coolers and the turbine lube oil reservoir. Additional plate filtration and demineralizer equipment is co-located here. Battery chargers and standby batteries are in separate rooms, along with a 480 volt switchgear and 4160 volt switchgear and breakers. An engineering station is located near the control system servers and allows for operational analysis of the plant system performance and adjustments to control system parameters. High voltage equipment is clearly marked for safe operations and allows for both local and remote control of electrical switching and energizing equipment. And all breaker and motor control center equipment is located in separate rooms on the mezzanine level and on other levels in the plant. On the east side of the plant building is the generator step-up transformer, the 4160 volt transformer, and bus bars carrying power to the disconnects and out to the grid. Power is generated by Aspen at 13.8 kilovolts and then is stepped up to the 138 kilovolt system voltage. Aspen Power has transformers for station service and also for power supply to the fuel yard. Aspen Power has a modern control room and requires the presence of one trained operator at all times while the plant is in operation. A state-of-the-art Rockwell digital control system, or DCS, is at the heart of Aspen's operations. A Woodward governor control system in Bentley, Nevada vibration monitoring systems are employed for monitoring critical turbine and generator speeds and vibration trip limits. The control room is appropriately located just off the turbine generator floor. Remote monitoring and cameras are employed throughout the plant for safety and the control room operator's visual access to critical external fuel flow at the metering bin and other locations. This is the turbine floor of the plant building. The turbine and generator are located inside the building and are protected from the elements. The plant is designed to generate 50 megawatts of net power to the grid, and since commissioning in 2011, the plant has delivered approximately 130,000 megawatt hours of power to the grid. This is roughly equivalent to 4 months of constant operation at full output. Although the plant has operated very little since construction and commissioning, the runtime has allowed for a proper shakedown and verification of equipment operation and plant reliability. The generator stator was upgraded with new larger magnets, and the output of the generator was increased to support the Aspen operational objectives. This is a GE turbine generator set. It's a robust and solid machine, and the unit has minimal vibration when running. The plant has been professionally laid up, and we are currently employing 2 professional operations staff in the completion of daily, weekly, and monthly checklists for preservation of equipment. The turbine and generator are rolled on turning gear on a weekly basis, along with other critical equipment, including fans, boiler feed pumps, condensate pumps, grate cooling pumps, cooling tower fans, etc. The Aspen plant has locker rooms with showers for both men and women. The plant also has a lunchroom and kitchen area for employees to gather and have meals. There are multiple offices, some with shared office space, and yet others for individual offices like the plant manager, the O&M manager, and the budget analyst. There's also a large conference room suitable for meetings. Most of the boiler-related equipment is located outside the plant. The boiler itself is located under a structure built specifically to support the boiler and cover the highest elevation, or penthouse. The Aspen plant has a large deaerator that provides for a positive head to the suction side of the boiler feed pumps. There is redundancy in the boiler feed system where only one boiler feed pump is required for operation of the plant. This level of redundancy applies to many other systems in the plant, including other pumps, fans, and motors. The boiler feed pumps are electric motor driven and connected to the 4160 volt system. There is also an emergency standby boiler feed pump powered electrically from the 460 volt system. This pump is installed to provide emergency cooling to the boiler in the event of a loss of the 4160 volt system while the plant is online. The plant is equipped with automatic rotary and direct steam powered soot blowers in critical areas of the boiler, including the economizer and other exhaust gas paths. The boiler steam drum is easily accessible for maintenance and operations staff located on the top of the elevation of the boiler house. The plant has a large ammonia tank with a spill basin for ammonia injection to the SCR. There is an inventory of spare parts available on site. Although the plant is located within the City of Lufkin limits, the property is large and the plant is situated well away from neighbors. Noise levels are minimal and well within permit limits at the fence line. In summary, The newly built Aspen Power Plant is a proven and reliable electric generation station. In 2014, the Aspen Power Plant was completely recommissioned, upgraded, and restarted by a world-renowned operator. Numerous upgrades to the plant equipment were completed to ensure safe and reliable operation. Recently, due to market conditions in Texas, the plant was idled and professionally placed into long-term layup status. As part of the preservation of the plant, 2 professional operators work full-time, performing daily, weekly, and monthly equipment checklists to ensure superior preservation of the equipment. The most critical equipment at the plant, the boiler and turbine generator set, are maintained with equipment to ensure low humidity and inert gas to eliminate corrosion. The turbine and generator are rolled on turning gear on a weekly basis, along with other critical equipment including fans, boiler feed pumps, condensate pumps, grate cooling pumps, and cooling tower fans, etc. The property perimeter is fenced, and the site employs full-time 24/7 professional security.